Welcome to video 5, which really continues the theme of moles that we were talking about in video 4. This particular video focuses more specifically on the concept of molar mass, but it's really kind of difficult to tease moles and molar mass apart, and we started to do some things related to molar mass in the previous video. But out of my desire to keep all these videos to be individually less than 20 minutes, I split this apart from the previous one. So let's talk about molar mass. So molar mass is essentially the mass of 1 mole of any substance. Okay, so, and since we talked in the previous video that Avogadro's number, the concept of the mole, its purpose is to allow you to be able to take atomic masses off of the periodic table and then convert them into molar masses by simply changing the unit from atomic mass units to grams. And so the mass in grams of a mole of any element is going to be equal in numerical value to its atomic mass. So if I've got 1 atom of oxygen that weighs 16 AMU, then if I've got 1 mole of oxygen, that weighs 16 grams, etc. And so a mole of carbon atoms weighs 12.01 grams, since 1 carbon atom weighs 12.01 atomic mass units. A mole of magnesium atoms weighs 24.31 grams. Again, I'm getting these numbers. These are just numbers right off of your periodic table. A mole of copper atoms weighs 63.55 grams. And so once again, the mole concept and the whole idea of that Avogadro's number is that there are Avogadro's number of atomic mass units per gram. So if you have a mole of anything, then its mass is equal to simply its atomic mass expressed in grams. So you'll hear some other names, and sometimes you'll hear these words come out of my mouth. Sometimes you'll see these words in your book. Molecular mass or molecular weight. I often, because in my previous life as a research chemist, we use the terms molecular weight and molar mass interchangeably, and in fact use the term molecular weight to mean molar mass. I will sometimes use those terms interchangeably. Technically, molecular weight or molecular mass refers to the mass of a single molecule. But since the quantity number is the same, just the unit is different, sometimes I will refer to molar mass as molecular weight. So if I say the molecular weight of water is 18.02, that means 1 molecule of water weighs 18.02 AMU, but also 1 mole of water weighs 18.02 grams. And so we use those terms. We can use those terms interchangeably. Formula mass, formula weight, similar. The numerical value is going to be the same. If we're talking about individual molecules, we're talking about AMU. If we're talking about a mole of the substance, we're talking about grams, but the actual number is going to be the same. The point is that you may hear me say all these terms, you may read all these terms, but you're always talking about the same number, same numerical value. It just one may be talking about a mole and one may be talking about a molecule, and so the units would be different. In the case of a molecule, it would be AMU. In the case of a mole, it would be grams. All right, so let's do a little learning check here. Get your periodic table out and find the molar mass rounded to the 10th place for 1 mole of bromine atoms and also for 1 mole of tin atoms. So once again, you're just going to read these things off the periodic table. Since an atom of bromine weighs 79.9 AMU, a mole of bromine atoms weighs 79.9 grams. Since a tin atom weighs 118.7 AMU, a mole of tin atoms weighs 118.7 grams. And I hope you got those answers. I'm sure you did. Okay, so let's talk about the molar mass of molecules and compounds. So we were just talking about the molar mass of an element can be found simply by reading that off of the periodic table. If we want to find the molar mass of a compound, whether it's a molecular compound or an ionic compound, we're just going to do the same thing as we were doing in the previous video when I was talking about finding the mass of a molecule of water or finding the mass of a molecule of Cl2 gas. We're simply going to add up the atomic masses of all of the atoms in the formula, and then we're going to express that as grams instead of as atomic mass units because we're talking about a mole. So if we're talking about the molar mass of calcium chloride, there are two elements present, calcium and chlorine. There is one calcium atom. So a mole of calcium atoms weighs, there's one calcium atom in the formula, so a mole of calcium atoms weighs 40.1 grams. There are two chlorine atoms in the formula, so I need 2 moles of chlorine atoms to complete a mole of my compound. So that's 2 times 35.5 is 71.0 grams. I add that up, and so the molar mass of CaCl2, calcium chloride, is 111.1 grams per mole. Just like a molecule of calcium chloride would weigh 111.1 atomic mass units, a mole of calcium chloride would weigh 111.1 grams. All right, that's an ionic compound. Let's consider a molecular compound, and the particular one we're talking about here is called dinitrogen tetroxide. What would be the molar mass of dinitrogen tetroxide? Well, one molecule contains 2 nitrogen atoms, and therefore a mole of it is going to contain 2 moles of nitrogen atoms. Each mole of nitrogen atom weighs 14 grams, and so the nitrogen in a mole of N2O4 is going to weigh 28 grams. There are 4 oxygen atoms in the formula, therefore we need 4 moles of oxygen atoms, each of which weighs 16 grams, and so the total oxygen mass is going to be 64 grams. We add that up, we get 92.0 grams per mole. So a molecule of N2O4 would weigh 92 atomic mass units. A mole of N2O4 would weigh 92 grams. Okay, pop quiz time. So you can take a look at these, turn off the video and work them with your periodic table, and then when you're done you can come back and check out the answers. Molar mass of potassium oxide, molar mass of aluminum hydroxide. Okay, the molar mass of potassium oxide, since there are 2 potassiums in the formula, we need 2 moles of potassium atoms. Each mole weighs 39.1 grams, so that's 78.2 grams potassium. There's 1 oxygen atom in the formula, so we need a mole of oxygen atoms. That weighs 16 grams. When we add those 2 things together, we get 94.2 grams per mole. And then the molar mass of aluminum hydroxide. It's important in looking at that formula to recognize that the parentheses around the OH with the 3 means that that 3 is distributed across both the oxygen and the hydrogen. So the actual formula of aluminum hydroxide has 1 aluminum atom, 3 oxygen atoms, and 3 hydrogen atoms. So we need 1 mole of aluminum atom, which weighs 27 grams, 3 moles of oxygen atoms, which at 16 grams apiece weighs 48 grams total, and then 3 moles of hydrogen, which at 1 gram per mole of hydrogen atoms gives us 3 grams of hydrogen, and that adds up to a total of 78.0 grams per mole of aluminum hydroxide. Okay, pop quiz, another pop quiz. Prozac, for which the formula is given there, is a widely used antidepressant, and it inhibits the uptake of serotonin by the brain. Determine the molar mass of Prozac to the nearest whole number. Okay, the molar mass of Prozac to the nearest whole number is 309 grams per mole. I'm going to actually do this in my head for a second. 17 times 12 for the carbon would be 180 plus 24 would be 204, plus 18 for the hydrogen gives me 222, 57 for the 3 fluorines, so 222 plus 57 gives me 279. 1 nitrogen atom is 14, that gives 279 plus 14 is 293. An oxygen is 16, 293 plus 16 is 309. So that answer is correct. Okay, let's talk about molar mass and its use in dimensional analysis, which is really the point of understanding molar mass and being able to calculate molar masses, is to use them in calculations. And so molar mass can be used as a conversion factor. We talked in the previous slide, in the previous video, I'm sorry, about the fact that a molecule of water weighs 18.02 atomic mass units. Therefore, we know that a mole of water weighs 18.02 grams. And if that's true, we can express that in two different ways, either as 18.02 grams of water per mole of water, or 1 mole of water per 18.02 grams of water. And we can use these conversion factors in dimensional analysis depending on whether we are converting mass to moles or moles to mass. Now, one of the things I'm going to give you guys toward the beginning of the year is a thing called a set of roadmaps. And roadmap number 1 has exactly to do with converting between moles and grams. And the idea of the roadmap is that simply you're going to get a type of problem where you're given some measurement, either the mass of the sample of a substance, or the number of moles of substance, or the number of molecules of the substance. You'd be given one of these 3 values and be asked to calculate one of the other 2, and you simply follow the arrows and do whatever operation it says above the arrow or below the arrow. So for example, if I'm going from grams of a particular substance to moles of that substance, I would divide by the molar mass. If I was going from moles of that substance to grams of that substance, I would multiply by the molar mass. If I was going from molecules to moles, I would, since that's going in that direction, that arrow underneath it, I would be dividing by Avogadro's number. If I was going from moles to molecules, going in that direction, I'd be multiplying by Avogadro's number. Let's see how this fits into actually the train track use of dimensional analysis that we've talked about before. So here's a practice problem. How many moles are there in a 50-gram sample of water? You can turn the video off for a second and try this if you want, using the roadmap. And by the way, this is in the worksheets folder, the roadmap. And then turn it back on. Okay, so in looking at the roadmap, we ask ourselves, what are we being given? We're being given grams of substance. What are we being asked for? We're being asked for moles of substance. And therefore, since we're going in this direction, that's the top arrow that's going in that direction, we're going to divide by molar mass. How does that look like on the train tracks? Well, we're starting with 50 grams of water. We want to get to moles of water, therefore we're going to put moles of water in the numerator, grams of water in the denominator, 18.02 grams in the denominator, 1 mole in the numerator. Effectively, we are dividing by molar mass, and we get the answer of 2.77 moles of water. And now we can do a more complex problem, and that is starting with that same measurement, 50 grams of water. How many molecules are there in a 50-gram sample of water? Again, you can go to the roadmap, and that will tell you that what am I being given? I'm being given 50 grams of water. What am I being asked for? I'm being asked for molecules of water, and so that is here. And so I'm going to follow the roadmap to get from here to here. So you can turn off the video for just a moment, try that, and then turn it back on. Okay, to get from grams of substance to molecules of substance, you're going to divide by its molar mass because the top arrow is going in that direction. Then you're going to multiply by Avogadro's number because, again, the top arrow is going in that direction. So to get from here to here, you're going along the top. You're dividing by molar mass. You're multiplying by Avogadro's number. How does that look in a train track setup? Well, here's my measurement that I'm starting with, 50.0 grams of water. I want to cancel out grams by using the molar mass, and so it's 1 mole over 18.02 grams. Then I want to cancel out moles and get to molecules by using Avogadro's number in this form with molecules on the top and moles on the bottom. So now I'm canceling out grams, I'm canceling out moles, I'm left with molecules. When I do the calculation, I get 1.67 times 10 to the 24th water molecules in 50 grams of water. Well, that's the end of this video. There are 2 worksheets for you to look at in the worksheet folder. and as well as a copy of the file that's got roadmap number 1. The 2 worksheets, one of them asks you to just calculate molar masses like we were doing earlier in this video, and you've got quite a few of those you can work on. The other one is really asking you to do these roadmap 1 calculations, and you may recognize a couple of problems on that second worksheet because they were on the worksheet for video 4 in converting moles to grams. I'm sorry, in converting moles to molecules. But the second worksheet, which is called moles to mass to moles to molecules, is going to ask you to do various roadmap 1 calculations. So enjoy the worksheets, and we will see you in the next video.